A 1-liter flask is filled with 1.20 grams of argon at 25 degrees Celsius. A sample of ethane vapor is added to the same flask until the total pressure is 1.100 atm. What is the partial pressure of argon in the flask? So, to get the partial pressure of argon in the flask, we will use the formula. So, partial pressure of argon, that is equal to the mole fraction of argon. So mole fraction of argon times the total pressure. Since the mole fraction of argon is not given in the problem, we need to solve first the mole fraction of argon. Okay, so the mole fraction of argon is equal to the moles of argon divided by the total moles inside the flask. Okay, so first, we can solve for the moles of argon because in the problem, we are given the mass, which is 1.20 grams. So let's solve first the moles of argon. That's just mass of argon divided by the molar mass of argon. So the mass of argon, it's already given in the problem. It's 1.20 grams. So 1 divided by the molar mass of argon, that's 39.95 grams per mole. So the grams would cancel out. So 1.20 divided by 39.95, that is equal to 0.03, approximately 0.03 moles of argon. Okay, so now you plug that into our equation. So our moles of argon is 0.03 moles divided by, now let's look for the total number of moles or the moles subscript total. So how do we now get this? So in the problem, there are other givens. We have 1 liter of the flask, that's a volume. We have the total pressure, which is 1.1 atm. We're also given the temperature, which is 25 degrees Celsius. So from this, we can actually make use of the ideal gas equation to get the total moles. So the ideal gas equation, if you can recall, that's PV equals nRT. So in the problem, we want to get the total number of moles, or N total. So N stands for moles, right? So N total, so RT. So if you're looking for N total, you will also use P total, or the total pressure. So P total times volume is equal to N total over RT. So if you want to get N total, you just divide both sides of the equation by RT. Okay? So if you do that, RT cancels on the right side. So you now have on the right side N total. And then you just substitute the values for the left side. So we have our P total, which is 1.100 atm, or 1.1 atm, times the volume, which is 1 liter, divided by R. So R is not given in the problem, but you should memorize the value of R. R is 0.0821 liter atmosphere per mole Kelvin. And our temperature is 25 degrees Celsius. But remember, if you use the ideal gas equation, the temperature must be in Kelvin. Okay, so how do you convert now 25 degrees Celsius to Kelvin? So to convert that, you need to add 273.15. So 25 plus 273.15, your temperature is 298.15 Kelvin. Okay, so let's see how the units cancel out. The ATM would cancel, the liters would cancel, the kelvins would cancel, so we now have moles as our unit. So if you solve that in your calculator, 1.1 times 1 on the numerator divided by 0.0821 times 298.15 in the denominator, you will get approximately 0.0449 moles. So this is your total moles. So now you plug that into our equation for mole fraction. So divided by 0.0449 moles. So solving this, the moles cancel out. So 0.03 divided by 0.0449. So the mole fraction of argon is 0.668. Okay, now that we have the mole fraction of argon, we can go back to this formula to get the partial pressure of argon. So let's do it here. So partial pressure of argon is equal to the mole fraction. So that's 0.668 times the total pressure, which is given in the problem, 1.1 or 1.100 atm. So if you do that, so 0.668 times 1.1, you will get approximately 0.735 if you round up atm. So the partial pressure of argon is 0.735 atm, and this is the answer to the question.